Hello, this is a lesson on the equations for inverse square law. We're going to look at the equations in one dimension, and then we're going to do a final problem in 2 dimensions. So we're going to start with the force of gravity, okay, which is Fg equals negative g for the attractive force, m1 times m2 d squared. So we have already done our step 2. Okay, kind of did it in order for our 5 steps. So first we need to knowns and unknowns. So force of gravity is going to equal, we don't know. Then we're going to do our g, which equals 6.67 e to the negative 11th. All right, and so we decided our 2 objects are going to be the mass of Earth, which will make m1. And so what is the mass of Earth? That would be in kilograms. And then we got our mass of our 2. Before we get there, we're going to talk about this constant real quick. There is a really big long unit for it. What ends up happening when we do all the math is all of those units cancel out, and we're left with newtons, which is the unit for force of gravity. So that makes sense. All right, and so then our second object is going to be Mars. And what is the mass of Mars? 23rd? 6.39, so this was all wrong. Okay, so 6.39 in kilogram times 10 to the 23rd. I also represent this times 10 by just putting a big capital E. Either or is good. When you're doing the math, just make sure you do it because it shows times 10. And then we need to know the distance in meters. And so what is the distance between these 2 objects? So our distance between those 2 objects is 6.4 e to the 10th meters. Okay, so now we have all of our knowns and unknowns. We have step 2, did it backwards, that's okay. So now we go to step 3, where we just plug in these numbers. Okay, so we will plug in those numbers. All right, so our plug and chug method, we got force of gravity. Okay, can't put that in your calculator. You're going to have a negative value. We know the negative's there, so you don't have to put it into your calculator. Just know that it will be a negative value when we're done, representing an attractive force. Okay, so then we have one big parentheses, and we're going to put our value for 6.67 e to the negative 11th. All right, times I forgot a parentheses, put a parentheses there before it, times 5.92 e to the 24th times our mass of our Mars, which is 6.39 e to the 23rd. And then we put parentheses there, and then we're going to divide it by our distance. And what we want to do is put a parentheses before that one, and you're going to go 6.4 e to the 10th. Now, what most people forget is their square up here. They forget their square. That's very important. So don't forget that square. You could put it inside the parentheses, outside the parentheses, whatever you want to do, and then go here with it. And then that should give you our force of gravity. Now, this number is negative, only representing an attractive force. Okay, I do want to see that negative there, though, so it shows us that we have an attractive force. All right, so your final answer should be, we have that negative because it's an attractive force, 6.16 e to the 16th. And we need our units, and since it's a force, it's going to be newtons. You could see that if you want to cancel out all of your constants. So that's going to be the Newton's universal law of gravitation and how you solve for it. All right, so now we're going to deal with electrostatic force. So again, we're going to do step 2 first, just so we know what equation we're using. Fe equals K times Q1. That's Q2, this is Q1, divided by their distance squared. So now we need to know our knowns and unknowns. So our first step, force of electrostatic force, we do not know. Our Coulomb's constant is 9 times 10 to the 9th. And we need to know our charge. What we're going to do for this one is the charge of a calcium chloride type reaction. So we need to know the ions for calcium, and we need to know the charge for the ions of calcium. Okay, so our charge for our calcium ion is going to be 3.204 e to the 19th, and our charge for our chloride is going to be a negative 3.204 times 10 to the 19th. Okay? And then we need to find our distance. So our distance between, we're going to go 2 average atoms was 10 to the negative 10th meters. It seems like a good number for me. So now we're going to do the plug and chug method, and again, follow my parentheses precisely. So we start with electrostatic force. It's going to equal parentheses, and then another one, 9 times 10 to the 9th times 3.204 times 10 to the 19th times a negative 3.204 times 10 to the 19th. Okay, so these are negative. Gotta keep that in mind. That's important. It's not a really big number. It's a really small number. Then we're going to parentheses, and then we're going to do our distance, which is 10 e to the negative 10th, and then we're going to square that. Okay. And then we're going to have to end with 1 parentheses here. And so then we're going to solve for it. All right, so our final steps, which is answer with units, is going to be a negative because it's an attractive force, the opposite charges, 9239 times 10 to the negative 10th, and our units are newtons. Again, if you would look at Coulomb's constant over here, you could get all the units you wanted to and find out how it cancels. But just know the number for the time being. So that is actually going to be 2 dimensions. We don't have time for or that was 1 dimension. We don't have time for the 2 dimensions. So look for another video on that.